A discussion of terminology at this point serves two functions. First, to make sure we're communicating using the same terms, and second, to provide an overview of things to come. Now, our terminology discussion will actually be divided into two sections: hardware terminology and software terminology. Software terminology will actually be covered in Chapter 2, but since hardware and software work so closely together, we're going to define both at this point. When we talk about hardware, we're talking about the physical components of the computer. For example, a monitor, keyboard, memory chips, hard drive. When we talk about software, we're talking about a set of instructions that directs the hardware to accomplish a task. Now, hardware and software work closely together to provide four functions: input, processing, storage, and output. Input through a keyboard or a mouse, processing through a CPU, storage in a permanent storage device like a hard drive or a floppy drive, and then finally output through a monitor or a printer. But computers use different languages than we use. Computers use a series of ones and zeros, which we call bits. The reason computers use bits is because they only know two states: on or power up, and off or power down. We'll be referring to bits many times during this discussion. Key hardware components include the CPU, or Central Processing Unit. It's the most important device in the computer because it receives input and sends output. It also stores instructions. And resources. Resources, for example, for a method for the CPU to communicate with a device, software to instruct and control a device, and of course electricity to power the devices. Common input-output devices include ports, which are physical connectors that allow a cable from a peripheral device to be attached. Input devices like keyboards, mice, or scanners, and then output devices like monitors, printers, or plotters. We can see ports on the back of any common computer. You've probably seen these on the back of a computer, and we'll be discussing in greater detail in later lessons what the different types of ports are. But there are parallel ports, for example, for printers, serial ports for other devices, there are network ports, phone ports, speaker ports. Inside the computer is the motherboard, the largest circuit board inside the computer. Permanent storage devices like floppy drives, hard drives, or CD-ROM drives. A power supply, which provides the power for the entire computer. Other circuit boards, and then ribbon cables, which connect everything together, providing data as well as electricity. The motherboard, the largest and most important circuit board, also contains the CPU, as well as many other pieces. For example, a chipset that supports the CPU. RAM, random access memory, which we'll discuss in greater detail in later lessons. Cache memory, expansion slots, buses, BIOS, and CMOS, which we remember are the essential elements to start a computer even without an operating system. And the motherboard also contains the electrical system. Components that the electrical system provides electricity and data to include hard drives, buses, and expansion slots. Types of expansion slots are PCI, which is used for high-speed input-output devices, AGP, usually used for video cards, and ISA slots, which are used by older and slower devices. We'll be discussing these in greater detail in later lessons as well. We can follow the logical path through the computer by looking at the bus lines on the bottom of a motherboard, starting underneath where the processor is installed. We can follow the bus lines through the motherboard to the expansion slots to see how everything is connected. Expansion slots allow the computer to be expanded with devices, for example, a sound card. This is a picture of a sound card installed in an expansion slot. Other types of expansion cards include a network interface card, an internal modem, an input-output controller card, for example, for a high-speed hard drive, a joystick card, possibly a video card. You can always tell a video card because it has a 15-pin, 3-row video port, and typically that's the only port that will be on a video card. Now, the component that keeps the heartbeat of the computer is the system clock, which is actually a crystal that oscillates, keeping the heartbeat and the timing of all of the components in the computer. The electrical system, powered by the power supply, supplies electricity in 3.3, 5, and 12 volts DC. Most processors use either 3.3 volts or 5 volts, and most electric motors inside a computer use 12 volts DC. The power supply connects to the motherboard to power all the devices in the motherboard, and then to the expansion slots for expandability power as well. BIOS is stored in a chip, and the chip is typically permanently installed on the board, but can be changed, which is called flashing the BIOS. If we do this change, we should be extremely careful, because an improper flash of a BIOS could render a computer completely useless. A safer method of configuration is CMOS. A CMOS chip holds information, but it can be changed using the keyboard in computer setup, and the information is held using a CMOS battery. We'll look at this in more detail in later lessons as well. Still, another device to configure computer components is a jumper. A jumper is a connector that, when installed, completes a circuit, and when it's not installed, no circuit is completed. There's some hardware terminology. Let's take a look at software terminology next.